Hi everyone, let's begin today carbon and its compounds. Okay, let's go into the topic. Carbon and its compounds. This is the topic that we are going to discuss. Okay, first we need to know about the introduction of the carbon. What is the symbol of carbon? Okay, the symbol of carbon is C, and we need to know its atomic number if we want to know its chemical reaction. So its atomic number is here 6. What do you mean by atomic number 6? Means here number of protons are 6, number of electrons are 6. So atomic number is generally denoted by the letter called as Z. Okay. Now let's go into its electronic configuration. Means electronic configuration means here distribution of electrons into their orbits. Now we have the case of first orbit, K orbit, where the number of electrons accommodated is here 2. Let's go into the second orbit, that is L orbit, where the number of electrons is here 4. Now, how many more electrons are needed for attaining its octet? Octet means 8 electrons they need it, okay? But number of electrons available are 4. So, it needs 4 more electrons in order to form a bond, okay? That means here to attain its complete stability. So, we say that 4 more electrons are needed. So, its valency is here 4. Okay, its combining capacity, which we call it as valency, is 4. And the electrons present in the outermost orbit are called valency electrons. So, its valency is 4. Valency electrons are also here 4. Now, let's go into the abundance. Means where are these present? In the Earth's crust. How much percentage of the carbon is present here? 0.02. In the form of what they are present? In the form of minerals like carbonates, coal and petroleum. So these are the products in which in the Earth's crust, means inside the Earth, how they are present in the form of carbonates, coal and petroleum. Now in the atmosphere, what is the gas present in the atmosphere? Carbon dioxide. How much is the percentage of carbon dioxide that is present here? 0.03% of carbon dioxide is present. Now, the carbon forms the foundational framework for all living organisms. That means here, carbon is very, very essential, okay, in our human life. In the form of what? We take the food, contains carbohydrates, okay. All that, whatever it is containing, all these are food items, okay. Food items contain carbohydrates which contain carbon in them. And we wear the clothes, for clothing also, preparation of clothes. And in order to move from one place to another, we use the fuel. Fuel is also made up of carbon. And the medicines that we take is also made up of what? Carbon. So carbon has very, very important role in our life. What is the important role in our life? Means it is present in the food, it is present in the clothing, it is present in fuels, and it is also present in the medicines, okay. Medicines also it is present. Now let's go into the next one here. Why carbon forms covalent bond? What do you mean by covalent bond? Okay, that we will be discussing here. Why carbon forms covalent bond here? So, to achieve the stability, because every atom wants to attain their stability. Okay, stability means what do you mean by stability? Here, when they get the, see for example, carbon has first orbit 2, second orbit 4. Now, in order to attain, how many more are needed here? Electrons, 4 electrons are needed. Okay, so now see here, stability means here, if a first orbit maximum capacity is here 2, second orbit maximum capacity is here 8. Okay, so if 8 electrons are present in the outermost orbit, it is called as octet configuration. What is this configuration called as? Octet configuration. Octet means 8. Octagon, you know the case of the octagon, how many limbs it has? Octagon would have how many limbs? 8 limbs. So octet of 8 electrons means outermost orbit contain 8 electrons. Now, but carbon has first orbit 2, second orbit is here, how much? Carbon, first orbit is here 2, second orbit is here 4. So, if it becomes this, first orbit is 2, second orbit is 8, it will attain its stability. So, we say carbon needs 4 electrons. How many more electrons are needed here? Already 4 is there. To become 8, it needs 4 more electrons. Now, what they say here, why carbon forms covalent bonds, not ionic? What do you mean by here ionic? Ionic means bond formed by transfer of electrons or gain of electrons. So, carbon neither transfers electron nor gains electron. So, therefore, carbon does not form ionic bond. So, ionic bond, in the case of the ionic bond, what takes place here? Transfer of electrons takes place. Transfer of electrons. Transfer of electrons from one atom to another atom. One atom to another atom. Why do they do transfer the electrons? Means they also wanted to attain their stability. Okay. But now in the case of the carbon, neither it transfers the electron. It does not transfer any electron. So that's why it does not form the ionic bond. Then what does it do? It will share the electrons. It will share the electrons. When it shares the electrons, it will form covalent bond. Okay. Now to explain that in a clear manner, we have taken that if carbon is there, in the case of the carbon, its atomic number, you know that it's a 6. K shell has 2, L shell has here 4. This is the nucleus of the carbon. Now first orbit will have here 2 electrons and second orbit will have here 4 electrons. How many electrons are there? 4 electrons. So in the center of it, the number of protons present, because carbon's atomic number is 6, number of protons present is here 6. Number of electrons also present is here 6. We know that number of protons is how many? 6. Number of electrons is also 6. Now we say that here, see, cannot gain 4 electrons. Cannot gain 4 electrons. So when it cannot gain, it will acquire a negative charge. It will acquire a negative charge. Whenever it gains, it will acquire a, see here, we have, see here, cannot lose. Whenever it cannot lose, it forms C4 plus. Whenever it cannot gain, it will form C4 minus. Now, let us understand it very clearly about this topic. Okay. Now, first see here, carbon's, the center or nucleus has how many? 6 protons. Now, let us say that here, it would be extremely difficult for nucleus with 6 protons to hold to 10 electrons. Now, if imagine the carbon is gaining here 4 more electrons. So number of electrons will become now here 10 and number of protons is here how many? 6. So this 6 protons cannot hold the 10 electrons. 6 protons cannot hold the 10 electrons. If it is gaining 4 electrons, now the if carbon gains 4 electrons, it should form C4 minus. What it should form? C4 minus. But 6 protons should hold 10 electrons. It is not possible. So we say that it would be extremely difficult for the nucleus of carbon which contains 6 protons to hold to 10 electrons. Now let's go into the case. Now 6 protons are there here. Now if it is losing 4 electrons, now these 4 electrons are lost. Number of electrons will become how many here? 2. Okay, this 6 protons can hold the 2 electrons, but it is very difficult for 4 electrons to remove. Why it is difficult for 4 electrons to remove? Because we need to spend a lot of energy. Okay, the electrons, when we remove it, that we call it as ionization energy. So ionization energy of it becomes very high. Okay, so when it is loose, it has to be taken, the 4 electrons have to be taken. Then what happens when it takes the 4 electrons here in the, from the carbon, if you take 4 electrons, we see that here what? The amount of ionization energy, okay, is immense. Immense means what here? Huge. Okay, the energy is very huge. You need to spend a lot of energy in order to remove these 4 electrons. So that's the reason it cannot form C4 plus. So loss of electron, we get the positive charge. Loss of electron. So carbon, if it loses 4 electron, it should get what? C4 plus. If carbon, if it is gaining 4 electrons, here it is losing electrons. Now it is here gaining electrons, then what it should form? C4 minus. But both are not possible. Both are not possible. Why the both are not possible? We have already discussed the reason behind it. Now let's go into the next topic. Okay. Now covalent bond. What do you mean by covalent bond? Now carbon, I said it cannot form ionic bond. Then what can the carbon form? So it will form the case of here covalent bond. What do you mean by covalent bond? A chemical bond formed by the sharing of electrons pairs between two atoms. So both attain the stable configuration. Both will attain the stable configuration. Now in the case of hydrogen, I took one atom called as hydrogen atom. Atomic number of hydrogen is 1. We know that atomic number of hydrogen is 1. Okay, so hydrogen atom has 1 electron, another hydrogen atom has 1 electron. Now what happens? This nucleus of this hydrogen atom combines with the nucleus of this, means this nucleus and this nucleus. Okay, now you have an electron here. You have electron here. This nucleus will attract this electron. This nucleus will attract this electron. Now what will they do? Their orbitals will overlap. And now they will share the electron. Each hydrogen atom will share the electron. Now both will attain a stable configuration. That is the stable configuration of here helium. What is the stable configuration here? Helium. Helium is the stable configuration of that element. And now both of them, since they are combining, they will form a molecule called as hydrogen molecule. But how many electrons are shared between them here? Only 1 electron. So we say one shared pair of electron, we call it as single covalent bond. Single covalent bond. Now take the case of here oxygen. Let us consider the case of the oxygen now. In the case of the oxygen, if you see it, take the case of the oxygen, the outermost orbit of 2 oxygen atoms. Now let us say here, this is 1 oxygen atom. Now outermost orbit will have how many electrons here? Let us say here 6 electrons. Another oxygen atom will also have here 6 electrons in the outermost orbit. Now each oxygen atom needs 2 electrons in order to attain its octet configuration. Now the nucleus of this, we have the, let us say that this is the nucleus, this is also nucleus. Now if how many electrons are there here? 2 here we have the case of it. Now here also how many are there here? Let us say 2 electrons are taking part. Here also 2 electrons taking part. Now this nucleus will attract these electrons, this nucleus will attract these electrons. Now this nucleus will attract here these electrons. Now what will happen? As a result of which their atomic orbitals overlap. When their atomic orbitals overlap, 2 electrons of this oxygen atom will share 2 electrons with this oxygen atom and they will attain their stability. Okay, and now 2 shared pair of electrons are taking part. So therefore we call it as here double bond. We call it as what? Double bond. Now if 3 pair, now look at the case of here nitrogen. How many electrons are there in the outermost orbit here? 5. How many electrons are there here? 5. Now in both the cases you can see that there are 5 electrons. In order to attain octet configuration, they need 3 electrons. In here, in order to attain octet configuration, they need 2. But here, in order to attain octet configuration, they need 1. So if 1 electron is there, 1 electron will be shared between 2 atoms. If 2 electrons are needed, 2 electrons will be shared between 2 atoms. If 3 electrons are needed, 3 electrons will be shared between 2 atoms. Now, when 3 electrons are shared between 2 atoms, it will form a triple bond. What it will form? Triple bond. Example of this is a nitrogen. Okay, nitrogen. We take one nitrogen atom, another nitrogen atom. This nitrogen atom has 5. Another nitrogen atom has 5. This nitrogen atom needs 3. Another nitrogen atom needs 3. So atomic orbitals overlap because we know nucleus will attract the electrons of the other atom. This nucleus will attract the electrons of the other atom, as a result of which their atomic orbitals overlap and they will share the electrons, and as a result of which they will attain the stability. So whenever between here hydrogen, if you draw a single line, that means it is a single bond. Now between oxygen and oxygen, when you draw two lines, it is a double bond. And between three lines, if you draw between nitrogen and nitrogen, it is a triple bond. What is it here? So we have one single bond, double bond, triple bond, which are formed by sharing of electrons. So we have discussed about the single bond, double bond, triple bond. There are some more examples of it, like chlorine. If you take a chlorine, okay, 7 electrons will be there in the outermost orbit. And how many more electrons are needed for octet means 1. So 1 chlorine atoms, like here, instead of this here, if you write here like chlorine, what is there in the outermost orbit? Another chlorine atom we can draw. And now here 1 electron is shared between 2. So both the chlorine atoms. Now what it will form here? Chlorine molecule. Chlorine molecule. Now similarly, in the case of this here, methane, this is called as here methane. And now this we call it as here ethene. And this we call it as here ethyne. Okay. Now we are going to discuss this in the next. Okay. Now let's go into this here. Now properties of the covalent compounds. What are the properties of this covalent compounds? Okay. They have low melting point and boiling point. Why do they have low melting point and boiling point? Because the bond formed between them is see here. A strong covalent bonds within the molecules, means inside the molecules the bonds are strong, but when compared to the outside, but weak intermolecular forces between these molecules. So when bond is formed, one molecule combines with the other, no. When one molecule combines with the other, inside the each atom the bond formation is strong, but when they combine it, their bond formation becomes weak. Now as a result of which they will have low melting point and boiling point. When you heat it, they will be easily, you can separate this. So as a result of which, what we say, weak intermolecular force of attraction. This is also called as van der Waals force of attraction. Now they are poor conductors of electricity. Okay, they are poor because there is no availability of free ions. If any conductors, when we will discuss, conductors have electrons, as a result of which they will allow the electricity to pass through them. Okay, liquids, we have positive ions, negative ions in the case of the liquids, and in gases positive ions are there, as well as here in the case of the gases we have positive ions. And we see here, let's go for the semiconductors. You have their holes and electrons, all will conduct, but here no free ions or charged particles are formed. In the case of which one? These are the properties of covalent compound. What are the properties of the covalent compound? Means they have low melting point and boiling point. What is the reason for it? Means they are poor conductors. See here, they have very weak force of attraction between them, and they are also what? Poor conductors of electricity, because no free ions or charged particles are formed there. Let's go into the next one. So these are called as allotropies. What are they called? Allotropies. Means all this, whether you call it allotropies, means occurrence of same element having same chemical properties but different physical structure. So when you talk about the case of the diamond, when you talk about the graphite, when you talk about C60, which is called as Buckminster Florence. Buckminster Florence. Okay, so either diamond, graphite or C60, all are made up of carbon atoms only. But why we call one as diamond, and why do we call the second one as here graphite? Why do we call the third one as C60? Buckminster Florence. Because see, the arrangement of carbon atoms is different in each of this, as a result of which what we say, these are called as allotropy forms of carbon. Now first let us discuss about this in detail. Now we have the structure. It is rigid 3 tetrahedral network. Means here one carbon atom, each carbon atom is bounded to 4 other carbon atom, forming a tetrahedral structure. Now this is the case of it. It is bounded to here 4 other carbon atoms. This is the tetrahedral structure in which it will be linking, self-linking itself, forming a substance which is a non-conductor of electricity. That does not allow the electricity to flow through it. But now, since it is a three-dimensional tetrahedral network, means it is a 3D plane. It will be in the 3D plane. Now, hardness and fuel. It is the hardest substance known. Natural hardest substance. So, what is diamond means? It is the natural hardest substance. Now, in the case of graphite, we can see the case of the graphite. Now, look at the case of it. The structure of the diamond already been given here side. So, one carbon atom linked to 4 carbon atoms and another carbon atom linked to 4 carbon atoms. We have seen here a structure of diamond here. Clear? Now, let's look into the case of the graphite. Okay, in the case of the graphite, they form a hexagonal layer. What do they form? Hexagonal layer. Each carbon atom bound to 3 other carbon atoms and one double bond. So, we have the case of the hexagonal rays arranged in layers. Hexagonal rays here. These are the hexagonal rays arranged in layers. And now, they are good conductors of electricity due to the free delocalized electrons per carbon. Now, here you see the case of when you draw here a line here, they are free about to move. Which one are free about to move? These layers are very free to move. When they are free to move, there will be an availability of a free electron. Okay, so when the free electron is available, they become a good conductors of electricity. Exceptional case. Okay, all other carbon compounds are bad conductor of electricity except the graphite, which is a good conductor of electricity. And now this is also used in the case of the lead pencils. So you can see a boy writing on a piece of paper. Okay, where he is using the, what is there in the case of the pencil means lead. Lead, what is this lead made up of here? Lead of that pencil is made up of graphite. The lead of the pencil is made up of graphite. So its soft and slippery layers slide over the each other. So now because of this one, the layer is there above the other, they are able to slide, because of which they are able to conduct electricity. Now look at the case of this C60, which is called Buckminster Florence. So it is in the form of a football-like structure containing how many carbon atoms? Means its name itself suggests that C60 means 60 carbon atoms are present. And what is that structure? It is in the form of a football. So this is also called as zodiac dome or football-like cage. Zodiac dome. Okay, zodiac dome or football-like cage. How many carbon atoms it contains here? 60 carbon atoms linked in hexagonal and in the form of hexagons and pentagons. So it contains, see here, total 32 rings, 12 pentagons, 20 hexagons forms 32 rings, 32 rings total altogether. Now it is a semiconductor. Semiconductor means partially allowing the current to pass through it, partially it does not allow the current. Okay, now unique electronic properties. Okay, so it's different from the case of which one? Diamond. Diamond does not allow the electricity to pass through it, but graphite allows the electricity to pass through it completely. But in the case of Buckminster Florence, it is a semiconductor. Unique electronic properties means partially allowing the current to pass through it. It is also smooth solid sphere. It's also, you can see the structure of it, which is in the form of a geodic dome or football like structure, which is depicted here. Okay, let's go into the next one. Now carbon forms, see, uniqueness of the carbon or versatile nature of the carbon. Why carbon is different from other elements? That is called as here versatile nature of carbon. Versatile means separate. Okay, why is carbon separate from the other elements? First thing, carbon forms millions of organic compounds due to major properties. Okay, it has got some qualities of it. What are these qualities which makes it special from the other elements? First one is called as here catenation. What is it known as? catenation. What do you mean by the case of here catenation here? See, let us look at the case of here. Okay, let's look at the case of the catenation. What do you mean by the case of here catenation here? The cell is the unique ability of carbon to form strong covalent bonds, with other carbon atoms, creating a long chain, branched chain, or a closed rings. So we see here carbon atom linked with a carbon atom forming a straight chain. Now carbon atom linked with a carbon atom and with the other carbon atom forming a branched chain. Now the same carbon atom will also form a ring-like structure. What does it form here? Ring-like structure. As a result of which this is called the uniqueness of the carbon, that is called catenation. Okay, the ability of a carbon to form straight chain, branched chain and ring-like structure. Okay, now carbon-carbon bonds are exceptionally strong. So when carbon is linked with carbon atom, they are very strong, because of which carbon's atomic size. So you see here carbon, small atomic size of the carbon. So why carbon has small atomic size means because it has strong what bonds here? Exceptionally strong and stable bonds. Okay, when carbon is linked with carbon. Now let's look into the case of tetravalency. What do you mean by tetravalency? The combining capacity of carbon. So carbon atom can combine with how many number of more carbon atoms? Means it can combine directly. One carbon atom can combine with 4 carbon atoms. Okay, as a result of which what we say here, the combining capacity of carbon is 4. Combining capacity of carbon is 4. Now this same carbon atom can be linked with hydrogen atoms. Same carbon atom can be linked with hydrogen atom. But how many hydrogen atoms combine with carbon here? Means 4 hydrogen atom. Here one carbon atom can link with 4 carbon atoms. One carbon atom can link with here 4 hydrogen atoms. So this is called as tetravalency. Carbon has a valency 4, allowing it to bond. See, carbon has a valency 4, allowing it to bond with 4 other atoms of other elements. What are the other elements that we have here? Hydrogen, oxygen, nitrogen, sulfur, chlorine. So these are the elements with which they can form. Okay, now multi-bonding. Okay, multiple bonding. What do you mean by here? Multiple bonding. So carbon forms single bonds, carbon forms double bonds, carbon forms triple bonds. Now carbon linked with carbon atom by a single bond, carbon linked with carbon atom by a double bond, carbon linked with carbon atom by a triple bond. So 2 carbon atoms, one carbon atom can link with another by single, double or triple. So this is the uniqueness of the carbon. So that's we call it as multiple bonding. So what are the 3 very important why versatile nature of the carbon? Why carbon is very important means first one, catenation, self-linking of carbon atoms to form straight chains, branched chains and ring-like structure. Now second one, what is the second one here? Tetravalency. So each carbon atom can link with 4 other carbon atoms or can link with 4 hydrogen atoms or like manner atoms like oxygen, nitrogen, sulfur, chlorine. Okay, as a result of which it is able to form large number of compounds. Next one, carbon can link with carbon by a single bond, carbon can link with carbon by a double bond, carbon can link with carbon by a triple bond. So as a result of which it will form multiple bonding. Now let's go into the next one. This is hydrocarbons. What do you mean by hydrocarbons? Okay, compounds. See here, these are the compounds containing hydrogen and carbon. Compounds containing hydrogen and carbon. Hydrogen and carbon are called as hydrocarbons. Now these hydrocarbons we divide it in the form of saturated, unsaturated. Okay, saturated and unsaturated. Now let us discuss about these are the classification of hydrocarbons. Okay, hydrocarbons are classified in the form of saturated and unsaturated. In the classification, we are going to discuss about saturated hydrocarbons. So saturated hydrocarbons comes first is the case of alkanes. What is it here? Alkanes. Now carbon atoms connected to only by a single bond. Now you can connect one carbon atom another by a single bond, or you can connect any number of carbon atoms by a single bond. So for example, if I take 4 carbon atoms, if I connect it by a single bond, all these are called as what? Alkanes only. Whenever one carbon atom linked with another carbon atom or more carbon atoms by a single bond, whenever there is a single bond, it is alkanes. What is it? Alkanes. Now, general formula of this. What is the general formula? CnH2n plus 2. CnH2n plus 2. This is a general formula of alkane. Now, what does N stands for? N represents here number of carbon atoms. N1 is the number of carbon atoms. Now, for example, if I take N value 1, now what I can write here? C1 H 2 into 1 plus 2. So what will become now here? C1 H4. Okay, now I got this here. C1 H4. What is this? Methane. What is it here? Methane. Now, if I take here C2, what will become here? H 2 into 2 plus 2. C2 H6. What I call it now here? Ethane. If I take 3, what will become now here? C3 H8, because I can put here C3 H 2 into 3 plus 2. It becomes what? C3 H8. So that is here propane. Okay, likewise if I put here 4, C4 2 into 4 plus 2, it becomes C4 H10. So this is called as here butane. Okay, now comparatively unreactive, because carbon-carbon bonds are very strong, they are unreactive. Next one, let's now see the case of it here. Now carbon is there. Now how many electrons are there in the carbon outermost orbit? 4. Now it is combining with how many hydrogen atoms? 4. So each hydrogen atom is sharing 1 electron, each carbon atom is sharing 1 electron. So it will form how much? 4 carbon hydrogen bonds. So all these are single. So you see in this figure that you can see here. Now look at this in this. In this here also carbon atom linked with carbon by a. So one single bond is formed between carbon to carbon. Okay. And now you can see here how many are there here. Carbon linked with hydrogen. Okay. Carbon is linked with hydrogen. How many they are forming here? 6. See, this carbon linked with hydrogen, this carbon linked with here, carbon linked with here, carbon linked with hydrogen, carbon linked with hydrogen, carbon linked with hydrogen. So each carbon atom, see here, each carbon atom linked with hydrogen is forming here 3 bonds. And now carbon with hydrogen forming 3. So total number of bonds formed. How many total number of single bonds are formed? Means there are 7 covalent bonds are formed. 7 covalent bonds are formed. Clear? Let's go into the next one. Okay. Now, in this case, let us see here. When N value is equal to, let's say here. Okay. Now, N value is equal to 1. Let us say N value is equal to 1. We got this. When N value is equal to 1, methane, CH4, the structure, carbon atom linked with 4 hydrogen atoms. So this is the case of methane. Its formula is CH4. Its structure, because how many carbon atoms? 1. How many bondings it needs here? Because its valence is 4. It can combine only with forming 4 bonds. So carbon, how many hydrogen are available? 4. So it will form all single bonds with hydrogen. Now methane is there, C2H4. Okay, 2 carbon atoms linked with a single bond. Each carbon atom linked with hydrogen by a single bond. Okay, so because valency of carbon is 4, you cannot keep more than 4 lines. For carbon, 1, 2, 3, 4. These are the valency of one carbon. Another carbon, since already it is linked 1, it will form 3. So as a result of it, this is a structure of ethane. Now similarly, propane, C3H8. Each carbon atom linked with single bond, and in turn linked with hydrogen also by a single bond. So it forms here 3 carbon, carbon, carbon. Okay, all have single bonds. With hydrogen also it forms single bonds. Now look at the butane, C4H10. Each carbon atom linked with a single bond, linked with hydrogen by a single bond. This is the structure of it. Now for pentane, you can see what is the formula, C5H10. But how did you get this all? Hexane, C6H14. So each carbon atom linked with by a single bond, linked with hydrogen by a double bond. Now here only we are going to apply the formula CnH2n plus 2. CnH2n plus 2. So this is the formula that we are going to apply. Okay. What is the formula that we are going to apply? CnH2n. Now put here n value 1. In this case here n value 2. Here n value 3. Here n value 4. And n value 5. N value 6. By putting these values you are going to get this formula. Okay. Which we have discussed in the before one. You can see here when I put 1 I got C1H4, 2 C3, C2 H6, C3 H8. Likewise for 4, 5, 6 if you do, you get this table. Okay, and then you can draw the structure of the alkanes. Okay, now let's go into the next one. Okay, now this is unsaturated hydrocarbons. What is this? Unsaturated. So when do you say it as unsaturated? When carbon linked with carbon by a double bond, or when carbon linked with carbon by a triple bond, you call it as unsaturated. When it is a double bond, you name it as alkenes and its general formula is CnH2n. And whenever it is here, look at triple bond. In the case of triple bond, carbon linked with a triple bond, you call it as alkynes. And what is it here? CnH2n minus 2. CnH2n minus 2. Now, highly unreactive. Which one here? These are reactive. See here, which are highly reactive compared to saturated hydrocarbons. Which are highly unreactive there? Alkanes were highly unreactive. Why they are unreactive? Because carbon single bond. But here, highly reactive. Why? Due to the presence of double bond, due to the presence of triple bond. So double bond and triple bond are weak bonds, whereas carbon only single bonds are very strong. So alkanes have a strong bonds, so they are unreactive. But alkenes and alkynes, due to the presence of double bond and triple bond, they are highly reactive. Okay, so highly reactive compared to saturated hydrocarbon. Now example of it. What is the example of it here? Ethene and ethine. So this ethene is an example of here alkene, and ethine is an example of here alkyne. Then how did we get this formula C2H4, C2H2? Because we have a general formula. What is this here? CnH2n. Now here, very important point to be remembered is that whenever we say here carbon double bond, n value must start from 2. N value starts from 2. And whenever we say carbon triple bond, n value should also start from here 2. Now put it in this here. When n value is 2, C2H, 2 into 2. So C2H4. Now put it in this here. What is the general formula? CnH2n minus 2. Now in this if you put here C2H, 2 into 2 minus 2. C2H2. C2H2. Now this is the formula that we got. Ethyne C2H2, we got it from this. And ethene C2H4, we got it from this. Because it's general formula. What is the general formula of it? CnH2n. And its general formula is what? CnH2n minus 2. Is it clear now? Let's go into the next topic. Okay. Now, these are the hydrocarbons, saturated and unsaturated. Okay, now I am going to discuss about the few. Like if I take n value is equal to 3. Okay, if I take n value is equal to 4. If I take n value is equal to 5. N value is equal to 6. This for which I am going to discuss here now, for alkenes. What is it here? Alkenes. When I take here alkenes, and general formula you know, CnH2n. Now for example here C3, N value 3 means C3, H 2 into 3. So what I get now here by doing it 6. So I get here formula C3 H6. Clear. Now if I take here C4, H 2 into 4 will become here 8. So I get the formula C4 H8. Now if I take here C5, H 2 into 5 will become here 10. This will become C5 H10. C5 H10. Now I get this here now. Now look at the case of it here now. C6 H 2 into 6, it will become 12. C6 H12. So these are the formula for what is this name of this N equal to 3. You call it as here propene. What do you call it as? Propene. N equal to 4, you call it as here butane. N equal to 5, you call it as here pentene. N equal to 6, you call it as here hexene. Okay, now see here, this is the case of it here. These two, just look at this here. This is called as here pentene, and this is called as here hexene. Okay, so these are the names of it that we have. Okay, so now structure. Whenever we ask here structure, 1, 2, 3, 3 carbon atoms are there. Okay, in this here we need to have the case of a double bond. One double bond is a must. Now I put a double bond between these two carbon atoms. But what is the valency of carbon? Valency of carbon is how much? 4. So already 2 bonds are there. 1, 2. But generally where the students make mistake is by keeping here 1. So number of bonds will become 5. Okay, you should not do that. Okay, so what is very very important is here, you should know that valency of carbon is here 4. So carbon can only form 4 bonds. Now already how much? 1, 2, 3, 4. So put the case of hydrogen here. Now this carbon atom linked by a double bond, carbon with carbon linked by a triple bond. Here also students make a mistake by keeping up and down. That is also a mistake because it will become 5. Only they should put 1 bond because carbon's valence is 4. Already 2, 1, 3 is there. This one 4. Hydrogen. Now this carbon atom has 1 electron. How many more are needed? 3. So you'll put a bonding here. Now just count the number of carbon atoms. 1, 2, 3. Number of carbon atoms are 3. Count number of hydrogen. 1, 2, 3, 4, 5, 6. Number of hydrogen atoms are 6. Now similarly for the case of it here. 1, 2, 3, 4. Okay. And 1 double bond if you keep here. It needs how many more? 2 bonds. 1, 2. For this already 3 are there. 1. This is already 2 are there. 1, 2. Only 1 is there here. 3 more. Put the case of here hydrogen in every case. Okay, every case we have to put the hydrogen. Whenever we put the hydrogen in every case, we will get the case of here the formula. And just let us count the number of hydrogen atoms. How many are there? 4. Carbon. 1, 2, 3, 4. Hydrogen, how many it should be there now here? 8. 1, 2, 3, 4, 5, 6, 7, 8. It is balanced. Okay, so now whatever the formula is that is the case here. So similarly likewise you can do for C5 and C5H10, C6H12. Clear? So this is all about the case of here alkenes. Now we have also one more, that is here alkynes. Here alkynes also N value equal to 3. Okay, we put the value. What is the formula here? Cn H2n minus 2. So C3H 2 into 3 minus 2. So what will become now here? C3H4. C3H4. Now root word is here prop, but we have to put here YNE. So it becomes here propine. Now here also root word is what here? Prop. Okay, but here we are putting here ENE. So it is becoming propane. So N value equal to 4. What it is now here? But plus YNE, butane. So similarly C4H 2 into 4 minus 2. So what will become here? C4H6. C4H6. Now N equal to 5. Let us put it here. This is called as here pentyne. And now C5H 2 into 5 minus 2. So this becomes C5H8. C5H8. So similarly we can also draw its structure. I will draw the two structures. Rest N equal to 6. What is it called as here? Hexene. Okay, hexene. Now put the value C6H 2 into 6 minus 2. So C6H 12 minus 2 how much? 10. Okay, now look at this here. Now how many carbon atoms needed? 3. But there should be only in one triple bond you can need it. Okay, so you can put the triple bond. How many triple bonds are there here? We need only one triple bond to say that it belongs to alkyne. Okay, now I have put one triple bond here. Now carbon has 3. How many more is needed? 1. So I put a hydrogen. Here already carbon 3 linked with 1, 4. Here how many needed? 3. Now let us count the number of carbon atoms and hydrogen. 1, 2, 3. The number of carbon atoms are 3. Hydrogen 4. I'll take the another one more. 1, 2, 3, 4. Here 3 carbon atoms. Okay, 4 carbon atoms are there. Between carbon I put triple bond. This carbon atom 1, this carbon atom 1. Now here already 4 bonds are there. For this 3 are there. We have to put 1. Here already 2 are there. We have to put above 1, below 1. Now here 1 is there. We have to put here 3. So whenever you are putting, count the number of lines. It should not exceed more than 4. If it is exceeding more than 4, that means you are crossing the valency of carbon. Okay, so which is not right. Okay, so that's what you have to keep it in mind when you put the, what does this lines indicates? It indicates the bond formations of carbon atom with the other element. Let's go into the case of it here. Now cyclic hydrocarbons. Okay, so saturated ring means carbon atom linked with carbon atom by a single bond forming a ring like structure. And now to satisfy the valency of it, what it can form a maximum of how many bonds? 4 bonds. So carbon, all carbon atoms, 6 carbon atoms are linked with single bond, and in turn linked with each carbon atom linked with the hydrogen, forming the case of a covalent. 2 hydrogen atoms each is linked. So you can write the structure as here CH2, CH2 in short. CH2, we will write here CH2, here CH2, and here also CH2. So everywhere CH2 is there. All are there in this ring. So 6 single bonded carbons. Okay, how many carbon? 6 single bonded carbons with how many hydrogen atoms? 2 hydrogen atoms. Okay, you see that there is a cyclic manner. This all looks like a cyclic manner. So that's why it is called as cyclohexane. What is it called as? Cyclohexane. What is the formula for cyclohexane? Count the number of carbon atoms. Carbon atoms are how many are there? 6. How many hydrogen atoms are there? Count now. 12. So total C6H12 is the formula for cyclohexane. Now unsaturated rings. Unsaturated rings. Now you look at this. Carbon atoms are bonded. Okay. But you see alternating double bond is present here. What is that? Alternating double bond. So it consists of 3 single bonds, 3. So carbon 3 single bonds and carbon 3 double bonds. Okay, this is a carbon 3 single bonds, carbon 3 double bonds. Okay, but how are they present? They are present here alternatingly. Why they are present alternatingly? Because this carbon atom linked with carbon by single, carbon with hydrogen single. So 1, 2 bonds. Now carbon must be linked with carbon by a double bond, so that the valency of the carbon is satisfied. And now this kind of structure with how many carbon atoms? 6 carbon atoms and 6 hydrogen atoms, where you have carbon single bond and carbon double bond, you call it as benzene. The structure is called as benzene. What do you call it as? Benzene. Okay, let's go into the case of it. Now structural isomers. What do you mean by the structural isomers? So they have same molecular formula but different structure. Now for example, here we have butane, C4H10. Okay, CH3, CH2, CH2, CH3. It forms a straight chain. You name it as what? N-butane or simply as butane. Okay, now count number of carbon atoms is 4. number of hydrogen atoms is here 10. So C4H10 is the formula for what? N-butane. Now similarly you can see the structure here. Down we have written 4 carbon atoms linked with the case of the hydrogen atoms. So each carbon atom is only bonded with how many bonds it is making here? 4 bonds only it is making. 4 single covalent bonds where valency of carbon is satisfied. Now here carbon atom linked with carbon atom, but here you see there is a branched chain. What is here? Branched chain. But for this kind of structural isomers, how many number of minimum carbon atoms are required? The question comes is here 4. How many? 4 atoms are required for minimum atoms required are 4. Minimum. Okay. Minimum atoms required. Minimum atoms required for branching. Required for branching are how many? 4. 4 in number. So that's the reason we say whenever we discuss about structural isomers, we start from the butane. Okay, so butane forms straight chain C4H10. Now it can also form a branched chain. Now when you count it here, now this is here 1, 2, 3. Okay, so in the third place when you come across, now let's look into the case of it. Now this is the case of 1, 2, 3. In the second place you see the branching. Okay, in the second place what you see? The branching. Now carbon atom has how many hydrogen atoms? 3. So this is called as here methyl. Carbon atoms with 3. You call it as what? Methyl. But where is it present? Second place. So 2-methyl. And now the straight chain. Okay, the straight chain, what is containing how many carbon atoms? 3. So you write it as here propane. What do you call it as here? Propane. So look at the case of it here. So 2-methyl propane, or what is the other name of it is isobutane. So isobutane means here this is the structure of it. Okay, whenever there is a structure like this here, this is the structure of iso. Okay, iso. So here carbon atom is 1 is there, so CH3. Here CH3. So when this kind of structure is there, this is called as iso. Okay, let's go into the case of the next one. Okay, now functional groups. Okay, before discussing these functional groups, we need to discuss one more group, that is called as here alkyl group. What is it called? Alkyl group. Now how is this alkyl group formed? Alkane is there, no? From alkane, when you take one hydrogen atom, we call this group as alkyl group. What do we call it as? Alkyl group. Now for example CH4 is there. From that if you take one hydrogen, what is it called as here? CH3. So similarly whenever C2H6 is there, from that if you take one C2H5. Now C3H8, from that if you take one hydrogen C3H7. So how is this formed? You know already that its general formula what? CnH2n plus 2. So here n value is equal to here 1, n value is equal to 2, n value equal to 3. We got these formulas. From that if you take one hydrogen atom, you get this. So that means this should also have a formula. Its formula is here CnH2n plus 1. Here n value starts from 1. Okay, so this is the case of it, which is called as the alkyl group. Generally we represent it by the letter called as what? R. Okay, now in this case here CH3, there is one empty is there. C2H5, one empty is there. C3H7, one empty is there. Okay, so that means here the valency of the carbon is not satisfied. In order to satisfy it, we add an heteroatom. What are the heteroatoms that we add? Like chlorine, bromine, oxygen, nitrogen, sulfur, or replace the hydrogen atoms from carbon chain, functional group that determines the chemical properties of that molecule. Now for example, I write here CH3. Okay, now let's go into the case of it. If we add chlorine or bromine, we call it as here haloalkanes. Haloalkanes. If we add the case of here OH, this group is called as a alcohol group. What is it known as? Alcohol group, because all of this contains heteroatoms oxygen. Now if you add CHO group, this is called as aldehyde group. If we add C double bond O, we call this group as ketone. And if we add COOH, okay, so if we add C double bond OOH, then we call it as carboxylic acid group. Let's go into the case of it here. Okay, now a series of compounds in which the same functional group substitute from the hydrogen in the carbon chain. Okay. Now what do you mean by the homologous series here? When we have taken such as here CH4, C2H6, C3, okay, C2, okay, let's just discuss about in the alkane CH4, C2H6, C3H8, okay, C3H8. Then we see the here, how many carbon atoms are there here? 2. Here carbon atoms are there 1. So difference of carbon atom is here C. Here to here difference of carbon atoms is here 2. So each parent group differ from one member to the other by a group called as what here? CH2 group. Now here difference is how much? C3. Difference is here 2. Now if you take the case of here C2H4, C3H6, C4H8. Okay, here also difference is how much? Look at this here. Difference is CH2. Here also difference is how much? CH2. So this is the case of your alkane. And now this you call it as here what? Alkane. What is it here? Alkane. Now look at the case of this is what your alkyne. In the case of the alkyne also let us take here C2H2, C3H4, C4H6. Now difference between them. How much is the difference here? CH2. So one carbon. What is the atomic weight of carbon here? 12. Hydrogen atom each 2 into 1. So difference is how much? 14 units. So we say successive members differ by 14 units in molecular mass. The successive members differ by CH2 group. So you see here from the case of methane to ethane to propane. So here ethene to propene to butane, ethine to propine to butane. All differ by a CH2 group, that is here 14 units. All members share similar chemical properties. So here carbon linked with carbon by a single bond, carbon linked with carbon by here a double bond, carbon linked with carbon by a here triple bond. So they have the same chemical properties. Next one, the melting point and boiling point and densities show gradual change as the molecular mass increases. Whenever the molecular mass increases, you see some change in their physical properties. What are the physical properties that you change here? Means melting point, boiling point and density. Okay, now let's go into the case of it here. Identify the longest chain. Okay, now if it is contained here 1, 2, 3, 4, longest chain. So root word, what is the root word that we use here? Longest chain containing 4. We use the word here bute. Now belonging to which one functional group? It is ANE. So we add here ANE. So what will become here? Butane. Okay, now if it is contained here 1, 2, 3. Okay, when it is containing 3, what do you add here? The root word is here prop. What is the root word we here? Prop. And here we have to add ANE. So what it will become? Propane. Now if it is containing only one carbon atom. How many? One carbon atom. So when it is containing only one carbon atom, its root word will come out to be what here? Meth. What is it? Meth. And what do we add to it here? ANE. Methane. When if it is containing here 2 carbon atoms. Okay. So what is the root word that it we get it here? Means eth. And to it what we have to add here? ANE. So it becomes ethane. So one carbon atom methane, 2 carbon atoms ethane, only when there is a single bond. Okay, if there is a double bond, now here, if there is a double bond between two carbon atoms, what do you call it as? Ether. Okay, this belong to what here? Alkene. So we have to add here ENA. So it becomes ethene. Carbon, triple bond is there. So here a double bond is there between two carbon atoms. One single bond is there. At that time, number of carbon atoms are 3. So you use the word here, prop. Plus you add here ENA, propane. Now if there are here 4 carbon atoms, one double bond, all other single. Longest chain is what? 4. 4 means what? Root word, bute. And to that what we have to add here? ENA, butane. Okay, now this is about the case of here, carbon here in that double bond. If it is present, we add ENA. Now if there is a triple bond between carbon atom, carbon, how many bonds are there? Triple bond. Then what do you say here now? Carbon linked with carbon by a triple bond. So root word is here what? 2 carbon atoms means ether. We have to add here YNA. So it becomes here ethyne. If carbon triple bond and one more carbon atom by a single bond. Number of carbon atoms are here 3. 3 means prop. Next one is here YNA. Now containing here 4. 1 triple bond, 1 single bond. Now 4 carbon atoms means root word bute. And you have to add here YNA. So it becomes butane. So basing on, if single bond, you have to put ANE, single bond ANE, double bond ENE, triple bond YNE. So these are the primary saturations. And now the case of it here, identify the longest carbon chain. So whenever you see a chain, you have to identify the longest chain and give the root word for that. Okay, basing on that, you can do the following. These are the nomenclature of it. Okay, so haloalkanes, when we discussed here, I said here, one chlorine atom from the alkane is removed. Now in this case here, just look at this C3H7, one hydrogen atom is absent. In that place where what you are adding here? Chlorine. Okay, so now this structure is called what? Because chlorine is given the first preference. Functional group chlorine is given the first preference. It is called chloropropane. What is it called? Chloropropane. And in this case here, OH, alcohol is added. So alcohol means OL. We have to add, what we have to take here, look at this here. Very, very important is here, longest chain we have to, containing single bond, propane minus E. Okay, plus if it is an alcohol, we have to add OL. So it becomes what? Propanol. What it becomes here? Propanol. Okay. Now, if it is the case of, if we add this structure, what is the structure that we are adding? C, here, C double bond O. Let's see here, C double bond O, and here hydrogen we are adding here. Let us say we are adding here hydrogen. Now, what is the structure here? CH. See here, there are CH2. Here double CH2. And now here we have containing 1. Now count the number of carbon atoms. Count the number of carbon. How many carbon atoms are there here? 3. So similarly, propane minus E plus, because it is an aldehyde, we add Al. What do we add here? Al. So what it becomes now here? Propanol. So here what do you write? Propane minus E plus Al. So propanol. So if you add the case of here, the group CO, it is called ketone group. What is it? Ketone. Propane minus E plus you have to add here propane minus E plus ONE. Propanone will become. Now here propanoic acid. Propane minus E plus OIC acid. So it is called as what? Propanoic acid. So this is all about the case of the functional groups that we have discussed. Okay. Thank you all. Give your valuable inputs so that we can, how many people are understanding, we can know it. Okay. Thank you. Bye.